spend a lot of time getting through every possible scenario that we may encounter on a racetrack and evaluating how to deal with that on the sim. The sim is super precise and is a great tool to help us achieve good victories and podiums on the racetrack. I knew exactly how much energy I had in my pocket just because we practiced so many races on the sim that when I arrived at the last lap, I knew exactly what I had to do to conserve enough energy to make an overtake in the last meters before the finish line.
So we are using then DIM so far for all the vehicle dynamics tuning, from the suspension in terms of comfort, ride and handling, the steering portion and the brake portion. I think our job with the DIM has been definitely faster, easier and safer. We believe we have cut at least 3 to 4 months from a normal vehicle development when it comes to the full dynamic development. Of course, it's a much safer tool compared to running in proving ground. We estimated that per each model we run around 2,000 equivalent kilometers of proving ground.
We pulled a video recording from an on-track tire test back in 2019 and made a comparison to the same section of track using the DIM 250 late last year. This is the same driver on the back section of Virginia International Raceway coming up on turn 13. Note the similarities between the two screens, including the representation of the track surface markings and the curbing which drivers rely on for these evaluations. We expect a reduction in the number of physical prototypes that will more than offset the substantial objective data collected during the virtual maneuvers and the complex detail of the tire and vehicle models.
We started to invest in our different development sites, Italy, North America, Brazil, on a tool able to give us the highest number of enablers acting on the vehicle under design. All our simulators are interconnected. Our global organization allows splitting part of the activity among the different sites. With the simulator, we can compare back-to-back several solutions in the same time frame. We can test different tracks without physical transfer, different components without waiting for the mechanical intervention in the vehicle. We have the same human in the same mood testing the alternative with the memory of the previous assessment, because the comparison is done in sequence. And is done in sequence with exactly the same road conditions without bias effects due to weather or other environmental factors. The simulation experience is not only a success in terms of time and cost compression, it is also an example of teamwork.
So having the driving simulator not only to create that zero gap between subjective and objective parameters, but to allow for the system integration and software development and functional safety requirements, again, has really expanded its use and has shortened the amount of time it takes to bring these electronically controlled systems to market dramatically. And you can see behind me the DIM 250 from VI grade, which has enabled us to not just do one segment optimization at a time, but to expand the segment that we can address all the way from large luxury sedans to off-road and on-road pickup trucks and SUVs. We're actually able to get the subjective evaluation in real time before we build a single prototype. That doesn't just bridge the gap, that eliminates the gap. That we've ended up with 8 times fewer valve code changes once we get to a physical prototype to bring that product to market. That translates into being able to get to that end of the development process in 25% of the time that it would normally take without the usage of these tools up front. We've been able to do more in 12 months on 3 different market segments of vehicles, including luxury sedans, sports cars, and pickup trucks and SUVs specifically, than we would have been able to do in 3 years' time.